Hi guys, let's move on to the next exercise. The next exercise is basically about slope and inclination. We've talked about this last year as well in grade 9, but let's quickly revise what we know about it. Now, angle, which is the inclination, is the angle which a line makes with the positive side of the x-axis. So inclination is the angle which any line makes with the positive side. Now, what does positive side mean? It means on the right hand side, which means, for example, if this line is passing through it, it is not, this is the positive side of the x-axis, which means towards the right. Perfect. So that's one. And the angle is measured in anti-clockwise direction. So anti-clockwise direction. So in this case, alpha is measured in anti-clockwise direction and it is acute. So this angle, let's say, is say 60 degree. So for this line, the inclination is 60 degree, or if I measure it in the clockwise direction, then this angle, yes, obviously will be 120 degree because this is a linear pair. So the inclination can also be written as negative 120 degree. So for this one, the inclination is either positive 60 degree or negative 120 degree. Let's look at the second line here. In now when I'm measuring this is beta. Now let's say this beta is say 130 degree. So my inclination is either positive 130 degree, or if I measure it in the clockwise direction, then it is negative 50 degree, because this will be 130 and 50, 180, because this is a linear pair. So the inclination is either negative 50 degree or plus 130 degree. Right. So that's about the inclination. So this is the angle between the line and the x-axis on the positive side. It is measured in the anti-clockwise direction, then it is positive. If measured in clockwise, then angle of inclination is negative. Perfect. So that's one key thing to remember. Let's look at this one where we talk about the slope. Now, what is slope? Slope is basically this the gradient that it makes, the line makes. So for example, let's look at these diagram that I have made here. I have line L1 and line L2. Which one visually do you think has more slope? Simple word which we use in English as well as physics. Yes, L2 has more slope than L1, because if I keep a ball here, it'll roll much faster compared to a ball which is kept here, because the gradient is much lesser in L1 and it is much more in L2. So slope, there are two ways of calculating slope. One is tan theta. And what is theta? Theta is the inclination. So we know the value of theta. We know the value of theta in the form of tan theta in the form of that standard angles, which is 0, 30, 45, 60, 90. Otherwise, we can look at the trigonometrical tables and figure out the value of tan theta. That's method 1 of calculating it. The method 2 of calculating it, of a slope of any given line, is y2 minus y1 upon x2 minus x1. So let a line pass through 2 points. Let point 1 be x1 y1 and point 2 be x2 y2. Then the slope of this line can be calculated using y2 minus y1 upon x2 minus x1. That gives the slope. Let's look at the last couple of points. In fact, let me remind you, some people use gradient also in place of slope, which means slope and gradient are used interchangeably in your book and by different people. So let's look at this one. For x-axis, what angle does it make with the x-axis? So if I have x-axis, what angle does it make with the x-axis? Yes, x-axis make an angle of 0 degree with the x-axis. So what would be the value of the slope of x-axis? The slope of x-axis will be m is equal to tan 0 degree. Therefore, m will be equal to 0, because tan 0 is equal to 0. Next, for y-axis, so let's look at y-axis. What angle does it make with the positive side of the x-axis? Yes, it makes an angle of 90 degree. So m will be equal to tan 90 degree, which, if you remember correctly, is infinite or not defined, right? Because this is 1 upon 0, which is not defined. So slope of a line perpendicular to x-axis is not defined, and slope of a line which is parallel to x-axis. So let's look at L3. This line is parallel to x-axis. What slope or what angle does it make with the x-axis? Well, it doesn't intersect with the x-axis at all, so it makes an angle of 0 degree with the x-axis, which means the slope of L3 will be equal to 0. Right? So any line which is parallel to x-axis, the slope will be 0 because the inclination is 0. So theta in this case is 0 degree and m will be tan 0 degree, which is equal to 1. So let's look at the next one. Let's see how we can move on from here and start solving some questions. Oh, before we solve questions, couple of more things. So if two lines are parallel to each other, they will have the same slope. Like we saw the example of x-axis and a line parallel to x-axis. So if I have, this is my x-axis and this is a line which we looked at in the previous question, L3. The slope of these two would be equal. Similarly, any two lines which are parallel to each other, slope will be equal. So if this is line 1 and this is line 2, m of line 1 will be equal to m of line 2, m being the slope. And there is one more thing that you need to remember from this exercise, which is the derivation of this is not there. But if two lines are perpendicular to each other, then what happens to the slope? So if these are two lines and they are perpendicular to each other, let's say this is line 1 and this is line 2, what can we say about the slopes of these two lines? Now in this case, what we can say is slope of line 1 into slope of line 2 is equal to -1. So that's a formula that you will need to remember. The derivation, like I said, is not in your syllabus, so I'll not get into it. What it means is m1 into m2 is equal to -1. Slope of line 1 multiplied with slope of line 2 is equal to -1. So this small simple formula will help you solve this complete exercise. So this complete exercise is based on these two concepts, which is two lines are parallel to each other, they will have the same slope. And if two lines are perpendicular to each other, if you multiply their slope, you will get -1. And then the last concept in this exercise, which is how can you figure out that 3 points or 3 or more points are collinear? I hope you remember the word collinear. Collinear are points which are a part of the same line. So how can I prove that A, B and C are collinear? Well, so let's say the slope of m of AB is equal to, let's say, 1. Now, what will be the slope of BC? Yes, the slope of BC will also be equal to 1 because this is the same line, and whatever is the inclination it's making with the x-axis, similarly it will be the same for BC as well. And what will be the slope of AC? Yes, the slope of AC will also be equal to 1. So you can prove that 2 or more points are collinear, rather 3 or more points are collinear if the slope of their respective segments and the total is equal. So in this case, all of them have a slope of 1. It could be whatever is the slope of different parts of the same line will always be equal. So let's look at some questions. I am on question number 1, part 3. So find the slope of the line whose inclination is 72 degree 30 minute. So slope will be equal to tan 72 degree 30 minute. We've learned how to read the trigonometrical tables last year. So I will just refer to the trigonometrical table and figure out the value of slope of tan 72 degree 30 minute. This is 3.1716. So that's the slope of the this line. Next, let's look at question number 2, part 3. It says find the inclination of the line whose slope is 0.7646. So I know that slope is given is equal to this, and I know m is equal to tan theta, which is given equal to 0.7646. Now I'll again go back to the trigonometrical table and look at what value of theta gives me a tan value of 0.7646. Now when I refer to it, I realize that this is 37 degree 24 minute. The last part of this question, which is question 2, part 4. Again, m is given equal to 1.0875, which means m is equal to tan theta is equal to 1.0875. Looking at the trigonometrical table to figure out where do I get 1.0875, I realize that theta is equal to 47 degree 24 minute. Maybe I'll make another video separately after this to revise how to read the trigonometrical table, but that will be after this. Let's look at question number 3. Question 3 says find the slope of the line passing through the following pairs of points. So I told you there are two ways of calculating slope. One is m is equal to tan theta, or the other one is m is equal to y2 minus y1 upon x2 minus x1. In this case, inclination not given, which means I cannot use this method. So let's use the other one. M is equal to y2 minus y1 upon x2 minus x1. So let's substitute. Does it matter whether I call this x1 or I call it x2? No, it doesn't matter. Whichever point I can call x1, whichever point I can call x2. So let's take x2, y2 as 1 and 2. So y2 is 2 minus of negative 3, which means 2 plus 3. X2 is 1 minus of negative 2, that's 1 plus 2, which means 5 upon 3 is the slope. So you can write your answer as m is equal to 5 upon 3, and that should get you full marks for this question. Let's look at question number 3, part 3. Again, we need to calculate the slope of a line which passes through the following points. So I know m is equal to y2 minus y1 upon x2 minus x1. Let's substitute. So let's take y2 as negative a minus of negative b, which means plus b, and x2 as b minus a. So this can be written, numerator can be written as b minus a, denominator is also b minus a, which means this is equal to 1. Therefore, slope is equal to 1 for this given line. I guess this is very simple. I hope you're getting the hang of it. Let's solve some more questions. Let's look at question number 4. Find the slope of the line parallel to AB. Oh, okay. So let me draw a rough diagram. So basically there is this line AB. Let's call this point A. Let's call this point B. And I want a line, slope of a line parallel to AB. So I need the slope of this line. So slope of AB will be equal to y2 minus y1 upon x2 minus x1, which will be equal to y2 is 5, y1 is minus 3, which means 5 plus 3, x2 is negative 2, and x1 is 0. So this is 8 upon negative 2, which means equal to negative 4. Since the required line is parallel to AB, therefore the slope of required line is equal to slope of AB, which is equal to negative 4. So the slope of the required line is negative 4. So M required line is equal to negative 4. So like I said, this exercise has three concepts. Concept 1, two lines are parallel, then their slopes are equal. Concept 2, two lines are perpendicular, then M1 into M2 is equal to negative 1. And the third concept being collinear points. So if 3 or more points are collinear, then the slope of their different parts will be equal. Let's look at question number 5, part 1. Find the slope of the line perpendicular to AB. So this time the line is perpendicular to AB. So let's first find the slope of AB. So slope of AB will be equal to y2 minus y1 upon x2 minus x1. y2 in this case is 4, y1 is negative 5. So 4 plus 5 upon negative 2 minus 0. That's 9 upon negative 2, which means negative 9 upon 2. So since required line is perpendicular to AB, therefore M of required line into M of AB will be equal to negative 1. Let's substitute values. So m of required line will into -9 upon 2 is equal to -1, which means therefore m of required line is equal to, let's cross multiply, -1 into 2 upon -9, which means 2 upon 9. So that's the slope of the required line, 2 upon 9. Yes, simple. Let's look at question number 6. It says the line passing through 0, 2 and -3, -1 is parallel to the line passing through something and something. So let's draw a rough diagram. Let's say this is my line here. So this is the line which is passing through 0, 2 and -3, -1. And this is parallel to another line which passes through this. Okay, so these two lines are parallel. This is for understanding. You don't need to really draw this diagram in your exam or for your exam. So these two lines are parallel. Let's call this AB and let's call this CD. So if I am giving names which are not listed in the question, then obviously I'll have to draw a diagram. So let's look at this. So m of AB will be equal to y2 minus y1 upon x2 minus x1. y2 is -1, y1 is 2, which means -1 minus 2 upon x2, which is -3, minus x1, which is 0, which means -3 upon -3, which means 1. So since CD is parallel to AB, therefore slope of CD is equal to slope of AB. So what do we need to calculate? A. Okay, so therefore slope of CD is equal to 1. Now slope of CD can be found using the formula y2 minus y1 upon x2 minus x1. So for CD, y2 would be A minus y1 is 5, x2 is 4, x1 is -1, which means 4 plus 1, and this is given equal to 1. Let's cross multiply. A minus 5 is equal to 1 into 5, which means 5, which means A is equal to 10. Let's look at the question. What do they want me to figure out? Find A. Done. A is equal to 10. Let's look at the next question. The next question that we solve is question number 7. Let's look at the question. The line passing through -4, -2 and 2, -3 is perpendicular to line passing through something and something. Find A. Again, a similar question like we did last time. So there is this line which passes through -4, -2 and 2, -3. And this line is perpendicular to a line which is, so this line makes a 90-degree angle with a line which passes through, let's say this point is A5 and this point is 2, -1. So these two lines make a 90-degree angle. Let's call this line AB and let's call this line CD. So let's calculate slope of AB first. So slope of AB will be y2 minus y1 upon x2 minus x1, which is equal to -3 plus 2 upon 2 plus 4, which means -1 upon 6. So -1 upon 6 is the slope of AB. Since AB is perpendicular to CD, what it means is slope of AB multiplied with slope of CD will be equal to -1. So I know the slope of AB, which means -1 by 6 into slope of CD is equal to -1. Let's cross multiply, which means slope of CD will be equal to -1 into 6 upon -1. Therefore, slope of CD is equal to 6. So we've got the slope of this line. Now what we know is slope of CD, which is equal to 6, can be calculated using the formula y2 minus y1 upon x2 minus x1. So for CD, y2 is -1, y1 is 5, x2 is 2 minus x1 is a, and this is equal to 6. Let's cross multiply. Negative 6 is equal to 12 minus 6a. Let's take 6a on the other side. So 6a is equal to 12 plus 6, which means 6a is equal to 18. Therefore, a is equal to 3. Yeah, that's about it. What did we do? We first figured out the slope of AB. Since CD is perpendicular to AB, which means the multiplication of their slope will give me -1, and that's how we moved on. So let's look at the next question. The next question is question number 8. Question number 8 says, without using the distance formula, show that these points are the vertices of a right angle triangle. So there are a triangle, but we need to prove that there are a slope of right angle triangle. So the only thing that we know about a right angle triangle is that the two sides, any two sides in this question will make an angle of 90 degree, which means if this is A, this is B, this is C, I don't know which one, which is the vertex angle, but anyway, which is the 90 degree angle, but I know that M1 and M2, so M1 multiplied by M2 will give me -1. So let's look at, well, let's first find slope of AB and then let's find slope of BC. Well, this is theoretical. I don't know which angle is 90 degree. Maybe it's angle A. So then we will have to look at slope of AB and AC. Let's first find slope of AB. So slope of AB will be 4 plus 2. Let's first write the formula. It will be y2 minus y1 upon x2 minus x1, which is 4 plus 2 upon -4 minus 4, which means this is equal to 6 upon -8, which means -3 upon 4. So that's the slope of AB. Let's calculate slope of BC. Slope of BC is 6 minus 4, yeah, y2 minus y1 upon x2. That's 10 minus -4, which means 10 plus 4, which means 2 upon 14, which is equal to 1 upon 7. I have done a mental calculation. If I multiply these two together, I am not getting -1. So let's try the slope of AC. So let's try the slope of AC. So y2 minus y1, which is 6 minus -2, which means 6 plus 2 upon 10 minus 4, which means 8 upon 6, which means 4 upon 3. Perfect. So if I look at the slope of AC and I look at the slope of AB, I realize that if I multiply them, there will be, I'll get -1. So let's try. M of AB multiplied with slope of AC gives me -3 by 4 into 4 by 3, which is equal to -1. Since the multiplication of slopes is -1, therefore AB is perpendicular to AC. So then what my diagram where I have taken my vertices is incorrect, but it's saying that AB is perpendicular to AC, which means the 90 degree angle is at A. This is AB and this is AC. So AB is perpendicular to AC. Yeah, that's perfect. So let's write the final answer because they want me to say that this is a right angle triangle. Since the two lines are perpendicular, therefore it is a right angled triangle. Perfect. Again, I don't expect such simple questions in your exam, but let's move on. The next question that we do will be question number 10. Let's look at question number 10. Question number 10 says, show that the midpoints of its side form a parallelogram. So these are the 4 points which are given, which are the vertices of a quadrilateral. We need to show that if you join the midpoints of these sides, then we will get a parallelogram. So let's first draw a rough diagram and see how we can move on. So let's say this is my parallelogram. Let's say this point is A, this is B, this is C, and this is D. So no point A, B, C, D not given, but so let's just write the coordinates. -2, 4, this is 4, 8, this is 10, 7, and this is 11, -5. These are the coordinates of the four vertices of a quadrilateral. We need to show that the quadrilateral operates joining the midpoint. So let's mark the midpoint. Somewhere here is the midpoint, somewhere here is the midpoint. So let's give it some name as well. So if I join these 4 points, what they want me to say is that what I'll get is a parallelogram. So let's give this a name, A, B, C, and D, and let's give this E, F, G, H. So what we need to prove, so to prove that E, F, G, H is a parallelogram. Now, how can I prove it to be a parallelogram? I can prove it to be a parallelogram if the slope of EF and GH is equal, which means a pair of opposite sides are parallel, and the slope of FG and the slope of EH is also equal, which means both pairs of opposite sides are parallel to each other, which means it will make it a parallelogram. So let's find the midpoint of the midpoint of the 4 sides. So midpoint of AB, we are calling it F. This will be equal to, using midpoint formula, -2 plus 4 upon 2 and 4 plus 8 upon 2. So F will be given as -2 plus 4, that's 2 upon 2, which is 1, and that's 12 upon 2, which means 6. So this is equal to 1, 6. Let's look at G. G will be equal to 4 plus 10 upon 2 and 8 plus 7 upon 2. So G will be equal to 14 upon 2, which means 7, and 15 upon 2. Let's for now write it as 7.5. Let's calculate coordinates of H. H will be equal to, is that 11? Yes, that's 11. So 11 plus 10 upon 2 and -5 plus 7 upon 2. Therefore, H will be equal to 21 upon 2, which is 10.5, and that's 2 upon 2, which means 1. And the coordinate of the last vertex, which is E. So E will be equal to -2 plus 11 upon 2 and 4 minus 5 upon 2. So E will be equal to, that's 9 upon 2, which means 4.5, and 4 minus 5, that's -1 upon 2, which means -0.5. That's the coordinate of E. So now let's try and prove that the slope of EF and GH is equal and the slope of FG and EH is equal. So let's calculate. So slope of EF. This is equal to y2 minus y1 upon x2 minus x1. Let's see what we can get. So what is y2 for EF? So we have E, let me just write it here, 4.5 and -0.5. F is 1, 6. G is 7, 7.5. And H is 10.5 and 1. So EF is 6 minus 0.5. So 6 minus 0.5. In fact, 6 plus 0.5, because this is minus of -0.5. So 6 plus 0.5 upon 1 minus 4.5, which means therefore slope of EF will be equal to, that's 6.5 upon -3.5. Let's multiply it with 2 to get a whole number. So this makes it -13 upon 7. So slope of EF is -13 upon 7. Let's find the slope of GH. So slope of GH. GH will be y2 minus y1, which means 7.5 minus 1 upon x2, which is 7 minus 10.5. 7.5 minus 1 is 6.5, and 7 minus 10.5 is -3.5, which is equal to -13 upon 7. So since slope of EF is equal to slope of GH. Therefore, EF is parallel to GH. Let's give them some numbers so that when we collate it finally, it'll be easier for us. So let's say this is 1, calculating G is 2, H is 3, E is 4, and slope of EF is 5, slope of GH is 6, and number 7 is EF is parallel to GH. Let's go to number 8. Let's figure out the slope of EH. So slope of EH, that will be 1 minus negative 0.5, which means 1 plus 0.5 upon 10.5 minus 4.5, which means 1.5 upon 6. So this will be equal to M of EH will be equal to 1.5 upon 6, which means 1 upon 4. Next, let's look at number 10. Let's find the slope of FG. So slope of FG will be 7.5 minus 6 upon 7 minus 1, which is 1.5 upon 6, which is equal to 1 upon 4. So this is my number 11, slope of FG. Since slope of EH is equal to slope of FG, therefore EH is parallel to FG. That's my number 12. Since both pairs of opposite sides are parallel, therefore quadrilateral EFGH is a parallelogram. Perfect. That finishes this work for us. Let's look at some homework questions for you. Let me just write the homework questions. Homework question for you would be question number 4, part 1, question number 5, part 2, and question number 9. Thank you so much. Take care. Be safe. Bye-bye.